Okay, so now I would like to continue with question 10. It says that object of mass 6 times 10 to the power of 3 suspended, okay, length, okay. And then they want to find the extension of the cable when the mass cable system is at rest, move outwards, constant speed dengan undergoes acceleration. Yeah, modulus is given, and that one is just acceleration of the gravitational acceleration. Okay, now, first of all, you have to draw it out first, and then after you draw, you have to take out the information. So they say that the mass is 6 times 10 to the power of 3. So in this case, you have a cable, and then you have a mass suspended the cable. So basically, this is, I just enlarged this cable, so this is basically the cable. The length here is 50 meter. So that one will be your L naught. Cross-sectional area is given. So A is equal to 2 times 10 negative 4. Determine the extension of the cable when the mass cable system is at rest. So if you use Young modulus formula, which is stress over strain, then this one will be F over A delta L naught. And the question want you to find the extension, so that will be your delta L. So that means delta L is equals to F L naught over A Young modulus. So you can see here, the only missing quantity is actually the force. So if I try to draw, let's say like this will be the tension that is pulling downwards to flow off the cable. So this is the applied force on the cable. And if you want to focus or you want to draw it over here for this mass, you will have tension and weight like that. And you know that this tension are equals, so basically it's same values, because this one is basically the same cable. So if it is A equals to 0 for the first case, it is at equilibrium, right? So you can see that if I do that summation of Fy equals to 0, then it will be tension minus weight equals to 0. So tension is simply weight. So this tension is the F over here. So weight is equals to mg, mass is 6,000 times with 9.81. 58860, and this would be in Newton. Okay, now if I substitute back inside this one, this equation, delta L, it will be 58860 multiplied with L naught is 50, area 2 times 10 negative 4, Young modulus is 2 times 10 to the power of 11. I got here is 0.0736. meter, or 7. 4 is okay. Okay, and then it says what happened if now it's moving upwards at constant speed. So constant speed, this one is for question B. So when it says that this one is constant speed, it means that A is equals to 0. So same cases with the equilibrium one, same case with the A. So basically, like this one, the answer will be the same because the force applied will be the same. So again, the L is equal to 0.0736 meter. And then the last question here, it says that what happened when the system move outwards at constant acceleration. So now, what happened if you have A in that direction? So the difference would be summation of F now is equals to MA. So tension minus weight is equals to 2 meter. 2m. So tension is equals to 2m plus mg. So mass is 3000. 2 plus 9.81. Is it mass 3000? No, mass is 6000. So the tension here would be 70860 Newton. And I can apply the same formula, this one. Oops. So delta R now is equal to 70860. R naught is 50. 2 times 10. I forgot already. 2 times 10 negative 4. This one is 2 times 10 to the power of 11. Let's double check. Yes. So here I got 0.0886 meter. You can write 0.089. Okay, next question. Dia kata a wire made of particle material is loaded with a load of 500 Newton. The diameter of the wire is 1 mm. The length of the wire is 2.5 meter and it's stretched 8 mm under load. What's the Young modulus of this material? I think this one is straightforward. Except that the part B, they ask you to find the strain energy per unit volume. So strain energy per unit volume is basically U over V equals to half stress strain. So maybe for question A, we can calculate stress and strain separately. So stress is force per unit area. Strain is delta L over L naught. Okay, so it says here that the load force is 500 Newton. Diameter of the wire is 1 mm, so R is equals to 0.5. L naught is 2.5 meter. Delta L is 8 mm. I substitute everything inside here. Okay, this one is a wire, so you will expect that the area will be a circle. Forget the square. So my stress here will be 6.366 times 10 to the power of 8. Okay, this one unit is Pascal. This one doesn't have any unit. This one is 3.2 times 10 negative 3. So Young modulus is stress over strain. .366 exponent to the power of 8 negative 3 1.99 times 10 to the power of 11. Okay, this one unit will be in Pascal. Okay, SI unit. Okay, and then for question B, they want to find strain energy per unit volume. So B here, U over V. Okay, don't get confused with strain energy. Stress, strain. If strain energy only is half, I forget the formula. Okay, anyway. That one would be force times delta L. Stress is 6.366. Strain So my strain energy per unit volume is 1.02 times 10 to the power of 6 joule per meter cube, because this one is per volume.
She says that she loves